Okay, in part 1 on solving equations, we looked at how we deal with one-step equations. Now in part 2, we're going to look at where there's more than one operation. Just a reminder of the principle that we discussed first. We had an unknown, a variable x we were trying to find, that was multiplied by 2. Our problem was that we want to know just what x was. So we worked out the operation that had been applied, in this case multiplying by 2, and then we applied the inverse to just get back to x. Now, let's try and do the same thing in a slightly more complicated scenario. Here we have a situation where x has had 2 operations applied. Can you spot those 2 operations? Remember to think about BIDMAS when you are trying to describe them. So, x has been multiplied by 2, and then 1 has been added to the result. So, we're going to apply the inverses. The question is, in which order? Well, what you need to consider here is an analogy, okay? And the analogy is socks and shoes. You put your socks on first, and then you put your shoes on. In what order do you take them off? You take your shoes off first, and then your socks. Let's see if this analogy works here. So, the first operation was multiplication, and the second was addition. So, what's our inverse operation to our adding of 1? Well, it's subtraction of 1. So let's take 1 off both sides. When I take 1 from this side, the positive 1 here is cancelled out. And I'm left just with 2x. That was deliberate. We deliberately took away 1 to cancel out the plus 1. Now look at what's left. How would we solve this? Well, we know that we've multiplied by 2, so we're going to divide by 2. Writing down your steps along the sides is a very helpful way of showing what you've done. You may not do that towards the end when you feel confident, but at the beginning it's very important. And doing it on both sides to make sure you're treating both sides equally. So when I divide by 2 over here, I get 3. When I divide by 2 over here, I get back to my original x. Now, so far, all of our answers in part 1 and in part 2 have been rather kind. let's look at a situation similar to this where the answer is not so kind. What operations are we going to apply to get down to x? Well, it's exactly the same as the first example. We're going to subtract 1 and then divide by 2. So I'm going to subtract 1 and I'm going to divide by 2. Can you see now why I chose this example? The answer I'm going to get here is not going to be a nice one. It's not going to be an integer value. It's not going to be 3, 4, 5, 6. It's going to be 2.5 or 2.5. The reason I do this example at this stage is I want you to be aware that not all of your answers will come out as integers. They could come out as fractions, they could come out as decimals, and they could come out negative. So let's have a look at another equation where we have two operations applied. The first thing to recognise is what those operations are. In this case, they are division and subtraction. So, we're going to reverse this process by adding 1 to both sides. Remember that this cancels out the multiply by 1. That is our aim, our purpose, to get rid of these two operations. Now, x has been divided by 5, so we're going to multiply by 5. Which will take me back to what x was originally. These are the basic situations you may face. There are some trickier ones we'll go through shortly, but let's look at one slightly similar for now. What are the two operations that have been applied? That's right. There is a x has been multiplied by 2 and divided by 3. If you remember, the reason we write BIDMAS like this is that it doesn't matter which of those two operations you do first. I'm going to choose to multiply by 3 first. Why am I multiplying by 3? Well, my fraction has been multiplied by 2 and then divided by 3. So I'm going to multiply by 3 and then divide by 2. So when I multiply this side by 3, I get 12. When I multiply this side by 3, it cancels out the divide by 3 and leaves me with just 2x. Now I divide by 2. And I get x equals 6. We will continue to look at two operation equations and move into some 3-part ones in the next video.